Hello, welcome back. Hearty welcome to you. So we are solving some simple examples as part of sequences and series. We are going through arithmetic progression and we are actually looking at the sum of or sum to n terms and solving problems on that. So we have a problem. Sum of first p, q and r terms of an AP are a, comma b and c respectively. Prove that a by q minus r plus b by q into r minus p plus c by r into p minus q equal to 0. We have been given that sum of PQR terms is equal to ABC. So let's put down the formula. We know formula Sn equal to n by 2 into 2a plus n minus 1 into d. So we'll just substitute that formula. After that we'll take it forward from there. Okay, right. So first I'll substitute what is S of P. Sum of P terms is equal to A. But what is sum of P terms? Sum of first P terms. S of P is nothing but equal to P by 2 into 2A plus P minus 1 into D is equal to A. Similarly, sum of first Q terms, R terms, I can write as it is S of Q, S of R. S of Q is Q by 2 into 2A plus Q minus 1 into D. I am not doing anything, just substituting in the formula. Similarly for S of R, it is R by 2 into 2A plus R minus 1 into D. That's equal to C. Now what we have to prove, if you look at it, I have to prove A by P into Q minus R plus B by Q into R minus P plus C by R into P minus Q. What I will do is, from this whatever I have, the first equation, P by 2 into this whole thing equal to A. If I take P that side, I will have 1 by 2 into 2A plus P minus 1 into D equal to A by P. So that I can find out the value of A by P, then I can multiply them as needed. So what I will write first, from here, from SP, I will get A by P equal to 1 by 2 into 2A plus P minus 1 into D. Similarly, B by Q equal to 1 by 2 into 2A. Actually, let me take it as A1 so that it will not conflict with the A we have here, right? So I will say 2A1. Okay, and D is the common difference. A1 is the first term of this progression. 2A1 plus Q minus 1 into D. What else we have? We have another one, that is C by R equal to 1 by 2 into 2A1 plus R minus 1 into D. This is what I have for A by P, B by Q, C by R. But what we need to multiply them with Q minus R, R minus P, P minus Q, and then add and prove them equal to 0. So what I will do, I will multiply this with Q minus R. Similarly, multiply this with R minus P. Multiply this with P minus Q. If I multiply that side, I should also multiply it here. Q minus R, R minus P, P minus Q. I hope I did it correct. Let me check it. A by P into Q minus R, B by Q into R minus P, C. Okay, right. Now you got it correct. Now, what we have to prove is sum of this is equal to 0. That means I should add on the right hand side all the three terms and prove that that's equal to 0. So let's do that. What we will do now, we will add right hand side whatever we have. What I will write is, I will say half of 2a1 plus p minus 1 into d into q minus r plus half of 2a1 plus q minus 1 into d into r minus p plus half of 2a1 plus r minus 1 into d that I have to multiply with p minus q. This I have to prove equal to 0. So what will be my next step is, what I will do is, I will take a1 terms separate. I will club them all, because you can see 2a1 I can take common. I will have q minus r minus p, p minus q, which will add up to 0. Similarly, I will take d terms separate. Then I will have p minus 1 into q minus r. Similarly, q minus 1 into r minus p and r minus 1 into p minus q. They also will become 0. So let us see. What I will do now, first I will say half of, this is nothing but equal to half of, can I say 2a1 into q minus r plus 2a1 into r minus p plus 2a1 into p minus q. That will take care of all the a1 terms. So then I left with something else. So let me just clear this. That's about the a1 terms. Now I have something else to take care, right? That is nothing but half into, I have taken a1 terms. Now I have to take care of d terms. So what will be the d term? Half into d, can I take it out because all of them have d? So it will be p minus 1 into q minus r plus q minus 1 into r minus p plus r minus 1 into p minus q. This is what? Right. Now you can take 2a1 common there. It will become 2a1 by 2 into, I have q minus r plus r minus p plus p minus q. That will make it, this whole thing to be 0. Now let me come to the next one. What I have here, plus d by 2 into, what I will do, I will separate these two terms. I will say p into q minus r minus 1 into q minus r, so that I can simplify them. I will have p into q minus r plus q into r minus p plus r into p minus q. That will be one set. What I will have, that will be one set. After that I will have minus, and I will have q minus r plus r minus p plus p minus q. This will be other one. Okay. Now you can see that r, p, q, cancels. This whole thing becomes 0. And you can also see here q, r, p cancels and you have this 0. And you can cross check that this also will become 0. What is that we are talking about? P into q minus r. Let me show it to you here. Just in one bit, one step. pq minus pr plus qr minus qp plus rp minus rq. You can see that pq, qp cancels, pr, rp cancels, qr, rq cancels. So 3 zeros. If you add all of them, that's nothing but equal to 0. So that is how we can prove that whatever is needed, a by p into q minus r plus b by q into r minus p plus c by r into p minus q equal to 0. What we have done? We have applied the formula whatever we know for sum to n terms, n by 2 into 2a plus n minus 1 into d. We have equated that to SP equal to A, SQ equal to B, SR equal to C. Then we try to get these values. A by P equal to what? B by Q, C by R. Now multiplied with the respect to what I need to multiply and added them together, you will see that they are all simplifying and they are becoming 0. We'll solve one more problem. Let us do one more problem. We have been given an arithmetic progression in which sum to n terms is given by 3n square plus 5n. Mth term is given as 164. We have to find out what is the value of m. Mth term is 164. Now, if I want to find out mth term, my formula will be, if a1 is the first term, I will say a1 plus m minus 1 into d equal to 164. Based on that, I should be able to get my m value. But for that, I should know what is a1, what is d. To find out a1 and d, I will use the formula whatever is that is n equal to 3n square plus 5n. First I will check what is s1, that is nothing but sum of 1 terms, that is nothing but equal to a1 equal to 3 into 1 square plus 5 into 1, that's nothing but equal to 8. We know a1 equal to 8. Sum of 2 terms, that's nothing but a1 plus a2, that's equal to 3 into 2 square plus 5 into 2. That's nothing but 2 2s are 4, 4 3s are 12, 12 plus 10, that is 22. Now you know a1 plus a2 is 22, a1 is 8. So you can write a1 is 8, a1 plus a2 is 22. That gives me a2 equal to 14. Okay, right. Now I can come back and say a1 equal to 8, a2 equal to 14. That gives me d equal to a2 minus a1, that's equal to 14 minus 8 equal to 6. Now I know the formula. What I have to substitute, that's nothing but here a1, that is 8, plus m, we have to find out the value of m minus 1 into d equal to 6 equal to 164. Now this is simplification. 6 into m minus 1 equal to 164 minus 8, that's equal to 156. So m minus 1 equal to 156 by 6, that's equal to 26. That gives you m equal to 27. So 27th term is nothing but equal to 164. So how we have done this? We have been given that the nth term, sum to nth terms is given by 3n square plus 5n. Now we use the formula a2 is nothing but equal to s2 minus s1. That is what we have used here. Using the formula we found what is s1, s2. We know a2 equal to s2 minus s1. Once I know a1, a2, I know d, common difference is nothing but a2 minus a1. So I know what is a1 and I know what is d. I know what is am, I have to find out the value of m. That I can easily find it out. We'll solve some more problems as part of arithmetic progression, sum to n terms. Thanks for visiting. Bye for now.